talk about the mean, we better start having something to write about. The mean value theorem. Not to be confused with the intermediate value theorem. Okay, here's what the mean value theorem says. Suppose that you have a function which rolls along merrily from this point, which is A, to this point, which is B. So here's A f of A, and here's B f of B. So let me connect the dots here with a different color. Let's have a nice friendly green. So if you connect these two points with a straight line, what's the slope of that line? Well, the slope of that line would be the average rate of change, and it's the difference in the y values divided by the difference in the x values. The difference in the y values would be, if this was a function f, then it would be f of b minus f of a, difference in the y values. Then you'd have to subtract the difference in the x values. That would be b minus a. So this quantity is nothing more than the average rate of change in going from this point to that point. It neglects how you got there. You may have been going very, very fast part of the time and tapering off the rest of the time, or you could have gone straight across or dipped down and then eventually sped up to get there. But the average is just the difference in the y values, how far you got, divided by how long it took to get there. This is the average, the mean. That's why it's called the mean value theorem. It talks about this average rate of change. And mean value theorem says that this average rate of change will actually have to be equal to the derivative, the instantaneous rate of change, somewhere in here. Now, if you look carefully, you can see places where the tangent line to this curve will be parallel to that green line. So let me pick a different color. Let's do red for tangent line. So I'm thinking that if you look right around here somewhere, like at that point, it seems to me that the tangent line right there would be pretty much parallel to that green one. If you look up here, somewhere around there, the tangent line is going to be parallel. Similarly over here. There's lots of places in this particular graph, well, maybe not lots, but 1, 2, 3, 4. There will be 4 places, I think, on this graph where the slope of the tangent line is the same as the slope of the line connecting the endpoints. The mean value theorem says that this has to happen somewhere at least. So, for instance, it would have to happen at this particular number. Let's call it C. So all the mean value theorem says is that the average rate of change equals the instantaneous rate of change for at least one, I'll say for some C between A and B. Okay, so somewhere between here and here, there's got to be a C with the derivative is the same as the average rate of change. Let's look at a particular example of that. Take our favorite example, f of x equals x squared. And we could sort of pick a random starting point. And let's take the interval from -1 to 3. Well, what would the average rate of change be? Well, that would be f of 3 minus f of -1 divided by 3 minus -1. So that's going to be f of 3, which is 9, minus f of -1, which is 1, divided by 3 minus -1, which is 4. So this is 8 over 4, which is 2. So on the picture, we should be able to draw the graph of this pretty easily. Y equals x squared, of course. We all know what that looks like. And if we go from -1 to 3, then we're connecting this dot and this dot. So we have a straight line connecting those. And what we just saw is that the slope of that line is 2. Mean value theorem says somewhere between negative 1, and 3, there's got to be a point that has the derivative exactly equal to that. And how are we going to find that? Well, that's not too hard. You take the derivative. Take the derivative, and that's going to give you 2x. That's the slope of the tangent line everywhere. But we don't care about the slope of the tangent line everywhere. We're looking for the slope of the tangent line at some point C, so that the slope of the tangent line is exactly to the slope of the line connecting the endpoints, the average rate of change. So what we want is for that to be equal to 2. And so, of course, x equals 1. And if you look at this picture, at 1, the slope of the tangent line at 1 will be the same as the slope of that line. So that's an example of the use of the mean value theorem. The mean value theorem turns out to be a very important theorem in mathematics, and I'm really unable to explain why it's so important at this level. It's just something that I have to teach right now, just so that you're aware of it. And it comes in handy once or twice in the proof of other things, but for your purposes, it's something to just file away, learn how to do it for the next exam, and then that's about it.